I've restarted. Okay, so I know we have all the variables we probably need. So looking at where we've kind of screwed things up, which variables are improperly calculated, and then which variables are being improperly used, because that we need to distinguish that difference here, right? Because tx and ty are not improperly calculated for the definition that we've given them. They're just being improperly used down here. And since they're being improperly used here, that means that these calculations here are completely off, right? So let's sure, why don't we just like highlight this whole thing and just make it kind of show up, right? So it really grabs our attention, so we know to come back to this. And do we have any calculation that tells us okay, so we could make a variable called LTX, and that would be for local tile X, to tell us what tile we're in. And I think we can calculate that like down here. I think it would be like something like var local tile X, and it's going to be like the viewport. Well, we gotta consider some offsets, right? Because this formula we're about to do is probably going to look a lot like this formula, but just done with the done with something. It's going to look a lot like this when we're done with it, I'm guessing. So the local tile X would be the viewport local X. And then we're going to divide by the size of a tile on the viewport. So TP0 width, right? The size of a tile on the viewport. And then we also have to like floor that. And do we already have our shorthand floor function? Yes, we do. It's right up here. So let's just put a F there for floor. And we'll duplicate this, LTX and LTY. So then let's say LT get local. What is the current tile value of the... So what is the current value of the pixel being drawn on the destination viewport, right? That's what we're doing. And let's move that over here like that so it all fits. Okay, what is the current tile value of the pixel being drawn on the destination viewport? And we forgot to change this, so we gotta change that to y's. So dx, dy, and the width and height of a tile as it appears on the viewport, and we can kind of scroll up and check that for a second. Size of tile measured in pixels as seen on the destination. So we are correct with the usage of the variable there. So this formula is correct. I'm fairly certain. Well, okay, well, it's almost correct. Because this doesn't account for any scroll. In fact, it doesn't account for any scrolling. And so maybe we want to scroll dx and dy. How would we do that? Well, dx and dy, because we're kind of like snapping to scroll dx and dy, if the source viewport is not at 0, 0, how does that change this? So if the source viewport is at 0, 0, this formula will work, but once we move the source viewport, like we move the camera somewhere, then this formula will no longer be valid. And why is that? Well, it's because we need to somehow offset the dx dy value by a certain value if we move the viewport. So it would be, if we move the source viewport 1 pixel to the right, we got to think that means we move the source viewport over exactly 1 tile. So we need to be like dx plus however big 1 tile is in pixels on the destination viewport. So so that would be dx, and then we're gonna add, and then let's just put some underscores here before we so we need this offset of the it's gonna be the so this would be source x times the size of pixel on, yeah, it'd be source x times the size of a pixel, size of a tile on the destination viewport, like that. And maybe make a little bit more room. And so that makes sense. Yeah, that should be about right, yeah. That makes sense to me. So then source y, right? So where the, ooh, not source y, right? Because source y is scanning over the entire source, but we don't want the value scanning over the entire source. We want just, well, hold on. Well, this source coordinate always represents a single tile, right? So if hold on, source x, source y, and that's an inclusive rectangle selection area, right? Let's go look at source x, source y really quick. Oh crap, that would have got me, because source x and source y is the tile x, tile y. Let's see, dx dy, sx0, sxy. So what's is anything iterating over here? Okay, you know what? I think so. Sx0. So the s underscore x variable should be between these values, and same thing with that. So let's see. Where do we have sx and sy? So these calculations here, sx, tile x, tile y. Okay, no, that makes sense. So we could have another sanity check in this code. So we're operating. Oh, lost my spot because I highlighted. Okay, so up here. I'm pretty sure this formula is correct because this is the current coordinate of the tile on the source. Aka the current coordinate on the off-screen buffer that we're using for our tile map. And just as a little sanity check, we can say that if sx should never be negative, well, if the viewport is somehow snapped out of bounds, or the viewport's if one of the viewport selection regions is outside of the data set for some reason, like we somehow moved the camera, or if we've moved camera out of bounds, like we're looking over the data set out of bounds, then this condition is going to be wrong. But I don't ever want to look out of bounds either. So this check is going to be indicative of either a problem within our formula, or the camera has been positioned incorrectly and it's currently like leaking off the edge of the data set somewhere. And I don't want to allow either one of those. So anyway, so if Sx is less than 0, or Sx is greater than or equal to, and we have a 512 by 512 map width, and I believe we have like map width, is this already in our code here? So we do have the width right here, so tilemap.map width. So we can just take this right here, and this is the how many pixels on the x-axis there are on the source viewport, right? Because the source viewport is composed of the source viewport is our tile map, right? So that's why it's tilemap.mapWidth, right? And then same thing for the y-axis. So we can make sure that so sy, if sy, and then map height, right? And then we can make a note that if one of these errors is thrown, it means one of. Error signifies one of these problems. Okay? One, camera is VP, so rec VP1, so the source, VP1 is the source camera, is not within bounds of tilemap. And the other problem could be that the calculations for Sx and Sy are wrong. Right? Also, we got to remember that Sx and Sx and Tx were the same variables. I believe that Sx, Sy is more explicit than Tx and Ty, because we're thinking about it as the coordinate on the source map. So we'll just throw an error, throw camera likely out of bounds, and then we'll put Sx like that, just to let us know that that's probably what's going on. Especially if after we've kind of hashed out these algorithms and we get them running, then it's even more likely that the problem is the camera is out of bounds, not that the calculations are wrong. Because once we get this running and going and we move on to something else, if this error ever happens, then it's highly likely that the camera is out of bounds, and very much less likely that the calculations are wrong, because we already wrote the calculations and we moved on. It doesn't say that it totally rules out number 2, because maybe some time has gone by and somebody touched the code in here that we're writing at a later date, and now this error is getting triggered because of case number 2, the calculations are wrong. But anyway, so we have that there, just a little error check, and also the error check also gives us a little bit of context of, okay, what Sx and Sy represent, so that when we're calculating this formula for the local tile X and local tile Y, it'll make it easier for us to wrap our head around it when we're looking at Sx and Sy here. So we have the local coordinates within the viewport, okay, and if these coordinates here equal 0 and 0, right, we're going to multiply that, and there's going to be no offset at all. So to figure out what tile value the destination viewport's pixel is in currently, all it is the local dx value. Ooh, local dx. This is not the local, is it? We want... let's go look at that for a second. And it's not, right? Because this is dx and dy is scanning over the entire canvas. And dx and dy... so first of all, let's think about this. Yeah, so dx and dy, they don't have to start at 0, 0. It's these LDX and LDY, because these are the local coordinates within the destination viewport, right? Because we've done the math here. So, so going back down here, we know that this needs to be LDX, and this needs to be LDY, right? So when we're scanning through the pixels on the destination viewport, these values, the first used value for these should be 0 and 0, right? Because we're going to start at 0, 0 when we're scan lining through the destination viewport. Well, as long as we are, in the valid region, right? Because if it's this, then dx and dy... If we're inside of here, then LDX and LDY would probably evaluate to some type of invalid negative value. But anyway, so let's go back down here. Okay, local coordinates within the destination viewport. And if the camera is not the camera that's looking over the tile map in the off-screen buffer, if that has not been moved and it's at 0, 0, then the Sx and Sy, also known as Tx and Ty, will both be 0, and if you multiply that, you're going to get 0, right? So that means there's going to be no offset, and to figure out what tile you're in, you're just going to divide by the size of a tile as it would be seen on the destination viewport. Now, if we move over our camera that is looking at the tile map data, if we move it over by 1 pixel, which is actually 1 tile, because each pixel on the source is a tile. If we move it over 1, if this value... hold on. So if this value here is 64, let's say that the tiles are currently being displayed as 64 pixels wide. So when we're offsetting, do we need to add... Are we off by 1 here with this calculation? So let's say LDX is 0 and this is 1. So we multiply it and we get 64. 64 would be the first pixel of the second tile, right? Because the 0 through 63 is the pixels of the first tile, the tile with tile index 0. And then 64 to 128 minus 1 would be the pixels for the second tile. So I don't think we're off by 1 here, because, right, this will give us 64 if this is 0, right? And so that gives us as we expect, that gives us the very first pixel of the second tile, aka the tile with index 0 on the x-axis. So I'd say that looks correct to me. And, right, so that whole range, so you're going to divide by 64, right? So if we are, so we can go, let's get up a calculator here. Oh, my timer's about off, but let's calculate this really quick. So if the LDX is 64, and we're going to divide by 1 times the width, which is 64. So divided by 64 divided by 64 is 1, correct? Right? So we floor that value, and we are at 1. We're not... So we're in tile index number 1. Now, if we did 64... Well, if we did 63, so let's say the pixel value on the destination viewport is 63 instead of 64, right? We divide that, and we get this fraction, right? It's not quite 1, right? Well, if we floor that, it's going to go all the way down to 0. So that 63rd pixel is within tile number 0. So this calculation seems to check out to me. And I think LTX, LTY... So I need to stop recording and re-record because I went over my 20 minutes.